Have you ever encountered a situation where your software seems busy, working hard, but never actually completes its task or makes any real progress? It is as if different parts of your program are stuck in a polite but endless dance, constantly deferring to each other. Livelocks can indeed be prevented effectively during the design phase by carefully implementing policies that ensure progress and break circular dependencies among concurrent operations. The core idea is to avoid situations where threads or processes repeatedly change their state in response to each other without ever advancing their overall goal. The fundamental reason livelocks occur is a deadlock avoidance strategy gone wrong. While deadlocks involve processes perpetually waiting for each other, livelocks involve processes continuously relinquishing resources or changing state in response to other processes, preventing any of them from completing their work. Imagine two people trying to pass each other in a narrow hallway, both repeatedly stepping aside for the other, but neither making it through. To actively prevent livelocks during design, consider these crucial strategies. First, introduce ordering into resource acquisition or access. If all concurrent entities attempt to access shared resources in a predefined, consistent order, it becomes far more difficult for them to get into a state of endless yielding. This breaks the symmetry that often leads to livelocks. Second, implement a mechanism for backoff or randomization. If a process fails to acquire a resource or make progress, instead of immediately trying again, it can wait for a random period or exponential backoff, giving other processes a chance to proceed. This randomness can often disrupt the cyclical yielding pattern. A powerful technique to consider is the concept of a token passing or priority system. In such a system, only the entity holding the token or having the highest priority is allowed to attempt its critical section. This ensures that at least one process can always make progress. Another approach is to use atomic operations and compare and swap instructions, which allow for optimistic concurrency control. This means processes try to make changes and then verify if the state has changed unexpectedly, retrying if necessary, often with a backoff. By proactively integrating structured resource access, introducing strategic delays, or implementing explicit progress mechanisms like token passing during your system design, you can construct robust concurrent applications that avoid the frustrating and unproductive cycle of livelocks. This foresight ensures smooth and efficient operation, allowing your programs to always move forward, rather than getting caught in an endless loop of unfulfilled intentions.
If this helps you fix faster, like, subscribe, and keep debugging with us.